Hey there, Algebra 2 students. This is Mrs. Anspaugh, and I am attempting my first ever flipped video. So my goal with this is that I can post this on the gradebook in PowerSchool, and that if you get on your gradebook at home or either at school sometime, you can actually watch these videos. Or you can just get on my YouTube channel and you can watch these videos as well. So these will be helpful to you as you prepare for the test next week. So what we're going to do today is I have one final aspect of the quadratic formula that I need to share with you, and it involves the D word, which is called the discriminant. And we use the discriminant to help us decide how many solutions we're going to have, whether we have one solution, two solutions, or sometimes no solutions. It's possible that our parabola will never touch the x-axis. So if you recall from yesterday, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, 2a. Yes, the songs are stuck in my head too. So what this formula allows us to do is that we actually use it to find the roots or the zeros or the x-intercepts of our quadratic equation. And if you remember, our quadratic equation actually has to be written in standard form. Y equals ax squared plus bx plus c, or sometimes we put 0 equals ax squared plus bx plus c. It doesn't matter. If we're going to graph it, we want a y equals. If we're going to use any other method, we want a 0 equals. So this D word, or this discriminant, it doesn't actually tell us what our solutions are. It actually tells us how many solutions we're going to get. And what we're doing, it's very simple, is we're looking at this area, this expression under the radical sign. This b squared minus 4ac, that is our discriminant. And it's used to find the number of roots, or the number of solutions. So what happens is, if you calculate the b squared minus 4ac, instead of calculating the whole entire quadratic formula, it will tell you how many solutions you should have. For instance, if you discover that your b squared minus 4ac, if your discriminant value is a number that's greater than 0, then that tells you you're going to have two real solutions, or two real roots, or two real zeros, or two real x-intercepts. If you discover that the value of your discriminant is equal to 0, so the two values equal 0, then you're going to have one real solution, or one real root. And if you discover that your discriminant is a number that's less than 0, so it's going to be negative, then you will have no real solutions, or no real roots, which means that your parabola will never touch the x-axis. So that's what the discriminant does. It does not tell us what our roots are, it just tells us how many we're going to get. So with that being said, let's actually look at an example. Here's a quadratic equation, y equals 2x squared minus 5x plus 3. And let's actually see what or how many solutions we're going to get. I don't really want to know what my solutions are. If I'm going to do that, I have to use one of my methods for solving quadratics. I just want to know how many solutions I might possibly get using this quadratic equation. So we need to start with what our A, our B, and our C is. So A is 2, B is negative 5, and C is 3. And so then we use our discriminant, b squared minus 4ac, and we substitute in our numbers for our variables. So we're going to substitute in negative 5 for b squared. Make sure you use parentheses. Minus 4 times, using parentheses, 2 times 3. And then we, of course, use Aunt Sally's order of operations to do our math. So we know we need to start with our exponents, and we end up with 25 minus 24, because 4 times 2 times 3 is 24. And 25 minus 24 equals 1. So if my discriminant is a number that's greater than 0, that 1 is actually greater than 0, then that tells me I'm going to have two real solutions. It tells me that this quadratic equation, which opens upward, it's pretty narrow, and it's going to cross the x-axis twice. Next example. y equals negative x squared plus 4x minus 7. Again, another great example of a quadratic equation. We can talk about how this opens downward. It's the same as the parent function. It's just shifted left a little bit, and it's shifted down a little bit as well. So now we're going to look at how many x-intercepts we have. Not what they are, just how many we might possibly get. So again, we start with our a, our b, and our c. A is -1, b is 4, and c is -7. And so we calculate the discriminant by using b squared minus 4ac. Substitute in your numbers. Remember to use parentheses. So when we substitute in for b, we have 4 squared minus 4 times -1 times -7. Now, a little helpful hint, when you have 3 or an odd number of negatives, you know your sign is going to stay negative. When you have an even number of negatives, you know it's going to turn into a plus. So when you use Aunt Sally's order of operations, and I suppose you could use your calculator too, but you end up with 16 minus 28. And we all know that 16 minus 28 is going to give us a negative value. We don't really care what the value is, we just know that it's negative. And since it happens to be a number that's less than 0, that tells me that my discriminant is going to give me no real solutions. My discriminant is less than 0, so this particular quadratic equation will never touch the x-axis. So I won't have any solutions. Now, we're going to learn on next week that if we don't get a solution, then it must be an imaginary solution. And I'll show you how to find out what the imaginary solution is next week. And then the final example here is y equals x squared minus 6x plus 9. And again, we begin with our a, our b, and our c. A is 1, b is -6, c is 9. And our discriminant is b squared minus 4ac. So when you substitute in your values for b squared minus 4ac, you end up with, again, don't forget parentheses, -6 squared minus 4 times 1 times 9. And Aunt Sally would appreciate it if you used her rules correctly. So this negative times a negative becomes a positive 36 minus 4 times 1 times 9 is 36. And this is an example where the discriminant is actually equal to 0. And we learned that if the discriminant actually equals 0, then this gives us one real solution, meaning this is going to cross the x-axis at only 1 point. And so we have one answer. So that takes care of the 3 examples, 1 solution, no solutions, or 2 solutions. Now let's look at 3 examples where we actually have to play a little matching game. We would want to figure out which of these 3 equations is going to represent 1 solution, no solution, or 2 solutions. So let's begin with number 1. Again, we need to start with our a, our b, and our c, and using the discriminant b squared minus 4ac. So when we substitute in our values, we're going to substitute in -1 for b, we're going to substitute in 2 for a, and 1 for c. And then when we do the math, again, use your calculator if you need it. If not, you can do the mental math. We all know that -1 squared is +1, and 1 minus 4 times 2 times 1 is 8. So 1 minus 8 is -7. So as soon as you see that your discriminant is a negative value, that means it's less than 0, so you're not going to get a real answer or a real solution. So that means your graph is never going to cross the x-axis. And that is example B of your graph. Number 2, y equals x squared minus x minus 2. Again, using the discriminant, we're going to substitute in -1 for b, we're going to substitute in 1 for a, and -2 for c. And then do the math. We end up with 1 plus 8 this time, because a negative times a negative is a positive, and 1 plus 8 equals 9. So since our discriminant is greater than 0, we know we're going to have 2 real solutions. And the only graph that actually crosses the x-axis twice is graph C. And of course, by process of elimination, I'm assuming our answers for number 3 is going to be A, but we'll go ahead and prove it by using the discriminant. When you substitute in B, you should be substituting in -2. A is 1 and C is also 1. So when you do the math, a negative times a negative, when we square it, becomes a +4. And 4 minus 4 times 1 is also 4. So 4 minus 4 equals 0. And since our discriminant is equal to 0, that tells me that I'm going to have one real solution or one real root, or one real 0, or one real x-intercept, whatever word you choose to use. And that is, again, is example or graph letter A. So last but not least, before we end our learning about the discriminant, I'm going to ask you to tell whether the vertex lies above, below, or on the x-axis. So beginning with the discriminant here, and knowing that this graph is going to open up, and it's also going to be fairly narrow because that's a whole number. It's not a fraction, so it's going to be a skinny graph. We're going to use the discriminant and determine if our graph is going to be on, below, or above the x-axis. So we're going to plug in -2 for B, we're going to plug in 3 for A, and 4 for C. And then we do the math using order of operations. -2 squared is 4, and 4 times 3 times 4 is 48. So we get 4 minus 48, which is a negative value. It's -44. So that tells me that my discriminant is less than 0, which means I'm not going to have any real roots. So let's think about this. If our graph opens up, which means it's spiraling, and it has no real roots, which means it's never going to cross the x-axis, is it above, below, or on the x-axis? And you might want to draw yourself a little picture, and that might help you. If it's opening up, but it does not cross the x-axis, then you know it's going to be above the x-axis. So the vertex lies above the x-axis. Now for example number 2. We know right away, because it has a -a value, that it's going to open downward. So it's going to be frowning at us. In addition to that, we can find out how many solutions it's going to have in order to see if it lies above, below, or on the x-axis. So substitute in 5 for B, substitute in -1 for A, and substitute in 1 for C. And so you end up with 25. And remember, a negative times a negative is a positive, and 4 times 1 is 4. So you end up with 25 plus 4. Which tells me that my discriminant is equal to 29. And so since that is a number that's greater than 0, that tells me I'm going to have 2 real solutions. So in order to determine if my vertex is above, below, or on the x-axis, you can draw yourself a little picture. It's going to cross opening down the x-axis twice. So my vertex is a maximum, and it falls above the x-axis. So we say that the vertex lies above the x-axis. And that, my friends, is the study of the discriminant. If you have questions, you can play this video back. You can access it on YouTube. You can access it on PowerSchool attached to your assignment for quadratic formula. Peace out.